And the distributed system can also improve performance. In a distributed database, you can distribute the data at each node according to um, according to different distribution and redundancy principle to construct a distributed system. So the most of the communication is completed at the nearby node, avoiding the complexity of synchronized database relational lookup. So if you are using a centralized database, there um, we want to um, we want to deal with the problem caused by multi-value and composite attributes. So we have multiple tables for an entire database. If we would like to find a certain type of data, there may probably is a complex process. It's a relational process to find this attribute of a distributed system. So because this database is uh, is flexible and it is capable to expand its size. So for we can store data without interrelation. So this increase the efficiency of accessing the data. And also the distributed system database system has good autonomy. The data in the distributed database doesn't have master-slave relationship logically, and the nodes are relatively independent. Therefore, the interaction between the data is highly autonomous, which means the needs of each department in unit to have its own data and maintain its own data. At the same time, I want to share data requirements of other departments based on department development needs. Our system can be distributed and it can work autonomously. And then we're coming to the topic of concept exploration. So the ideal distributed system has clear engineer goals in implementation, including logical node autonomy. Nodes are highly autonomous. Each node in the network is an independent relational database that can independently complete local tests, implement applications, and exist as a data node in a distributed network. So for each node, it is a relatively small centralized database, so you can basically complete 19% of your work in your local database. Um, but it is also has highly autonomy, so you can easily access its nearby node to achieve a complicated task. So for the most of the tasks can be achieved as a local node and nearby nodes. It also doesn't rely on the central node. Each node has global dictionary management, query processing, and concurrent control, recovery control in multi-thread environment. So it is not It is not a master slave system, which means all nodes share equivalent rights and uh, and they don't need to call each other for for the most of queries, and the queries has concurrency, which means the task can be complete com- can be done at a local node or nearby nodes in parallel, and it's it, it increases the efficiency of the whole database system. And also the distributed system has continuity. When the operable targets in the distributed database are constantly getting lost, when one or more new threads are integrated in the existing distributed system, it will not cause any unnecessary service interruption. It can be dramatically changed in the distributed system, established and eliminated segments without stopping any part of the site or database. Whenever possible, upgrade the DBMS of the site that makes up the distributed system without shutting down the entire system. So which means you can imagine that for a centralized database, you can shut down the entire system for a single second. But if you what if you would like to update your system or reorganize your system? It would be highly cost. But for a distributed system, it will be much easier. Much easier because for a single node, it is totally okay if it shut down for a while. You can access your data from the mirror copy from your nearby nodes. So the entire system will not be shut down. And it also has transparency. The user doesn't know the storage location of the data in the distributed system. Data replication performance. Data on the physical side can be stored, copied at multiple nodes. A system that supports data replication should support replication independence, and users can work as if they had no storage copies at all. So, which means the copies of the data, the process of copy of the data is totally unaware to the users. So the rebuild and restore of the data can be done automatically without cause any interruption and discontinuity of the entire system. So it also supports distributed transaction management. There are two main aspects of the of the transaction management: recovery control and concurrency control. In a distributed system, a single transaction will involve code execution on multiple venues, and it will involve updates on multiple venues. Especially, specifically, it refers to reply control and concurrency control in a multi-threaded environment.